So before the ROV, we were really stuck on shore, quite literally, which wasn't a bad thing at first, but when we got the right funding, we were able to expand our research, which then opened up a plethora of different types of programs. I mean, we're in a fjord with 300 meters of depth, so we get to explore areas that a scuba diver will never be able to go. So it's definitely brought us to new heights.
The main goal for most marine science customers is collecting data underwater. Two of the ways that people usually collect data underwater is either with drop sensors or samplers, or putting divers in the water to collect that data for them. Divers are a great resource for underwater researchers, but using divers can be time-consuming and costly. And if we don't know enough about what's underwater, it can be a dangerous situation for them as well. So using these traditional research methods can be costly. And if researchers consistently have to buy new sensors or new equipment every season, it can be difficult for them to complete their research within their budget. So if researchers don't have access to the tools that they need, they sometimes opt out of collecting that data altogether or using inadequate tools in order to collect data, which can be inconsistent.
So before we had ROV, we had to schedule all of our work with divers. So of course, we would have to have the divers to go down and conduct all our surveys. Or in some cases, we would try to do it while we were snorkeling in the more shallow bays, but it requires more people, it's less safe. It really constricts your ability to schedule because you need more people involved, and it's the type of work where you have, if you get a good weather day, you have to go. And it also is a lot more expensive to pay for divers.
An ROV, or a remotely operated vehicle, is an underwater robot that can collect pictures, video, sonar data, and many other different kinds of telemetry underwater. So the benefit of using a deep trekker ROV is that they're portable, they're rugged, and they're easy to use. Whether you're launching off a ship, off a boat, or in a remote area, our ROVs you're going to be able to take there, give to any member of your team, and collect quality data.
The ROV comes to us, it's easy to use, it's ready to use, we don't have to do anything ourselves, so that we aren't mechanics, we don't have that knowledge set, so be able to just throw our ROV in the water and it works the way we need it to is why deep trekker works for us.
It can seem daunting at first when you open up the cases and you see all these cables and all this equipment, and it's like, what does any of this even do? And then once you get out in the water and you start using it, you realize that it's not really that complicated and it's a lot of fun.
So a traditional method for species and habitat monitoring often include divers or camera systems that are drop or stationally mounted. So using a drop camera system or a stationally mounted camera system that's submerged underwater can be useful, but it also is limiting in terms of getting data in different areas. Using a drop camera that's stationally mounted will give you good data in one spot, but if the water clarity is poor, then you're unable to see, or if you have a species swim by and you would like to collect data and follow that species, see if there's more around it, you're unable to do that.
When you're one person with a camera taking pictures at certain places, it's kind of just a snapshot in time, whereas like with the ROV you can kind of reach a wider range of the eelgrass and get a bigger picture of what it's looking like.
ROVs are a great tool for visual applications underwater because they give you a platform to collect data that is safer, faster, and easier to use than traditional methods. ROVs aren't just a traditional camera system. You can also add things such as sonar to them to help deal with murky water. And we also have a turbidity filter that can be used with your video to help bring forward more details even when the water conditions aren't great.
When we first put it in the water, I was really surprised with just how clear it is and being able to see little details.
We can get close enough to see even the small fish going in and out of there and be able to identify the species with pretty good accuracy.
Using divers for species and habitat monitoring is a great tool. They're able to get down and follow around fish or other species that you're looking at. They're also able to evaluate the environment that they have in front of them. One of the limiting factors to divers, though, that we consistently see is depth and not having the divers be able to go deep enough in order to collect the data that's required.
Having an ROV has allowed us to explore areas here in Gross Moen and in Bombay that have never been researched before. So it's beyond the depths of traditional scuba diving that so no one was going down there and no one was able to see.
ROVs are a great tool to use with divers as a team. So if you're doing research within the range of where divers can go, having an ROV adds a safety element to having them underwater. You can do pre-inspections to make sure that there's no hazards for the divers when they're under the water doing the job, but you can also have an ROV in the water in tandem with the divers, so you're making sure to monitor their safety in real time.
You can put a camera down, you can use a drop camera, you can use telescopes, you can do scuba diving and snorkeling. But the use of ROV, I think, is something that a lot of organizations are starting to use and utilize because you can go deeper depths. It's more safe than actually putting human bodies underneath the water.
This is such a great way that we can get into the water, and I always call it like virtual snorkeling. We get people kind of in the water through a virtual sense, and it streams footage live to all of the screens, and it's so cool to see everybody's look on their faces when they see this underwater habitat right in front of them and they're just floating right on top of it, and it just gets more of that connection from the person to the habitats we're exploring.
So marine scientists also look to capture physical data from underwater. That includes water sampling, sediment sampling, and also water quality analysis from those samples. Some of the traditional methods for collecting this data is dredging, core sampling, grabbing underwater, and those can collect good data, but the thing that you don't have when you use that is accurate information about where you're taking that sample or what it looks like where you're taking that sample. The great thing about using an ROV for collecting samples is that you're able to make the decisions of where you take your samples from. You can use the visual data to collect accurate samples while also locking your location of where that sample's been taken. This gives you the ability to revisit those locations at a different time and reevaluate the data that you can see then.
For a certain area, and you use your lat and long, and you can always go back to the same area and do the exact same spot and see the differences throughout the year.
Before we were like driving in the dark. Now we can find out where we're to and we can put in our grids.
So you can either pre-plot your missions and send the ROV out to certain locations with points of interest, or you can live dive, send the ROV out, drop points of interest while you're piloting, and revisit them at a later date.
So with the mission planner, all we'd have to do is just plan our transects. So we punch them in, we hit start, and we got it. Everything is already populated. It's fantastic for what we're doing.
So traditional methods for collecting bathymetric survey data is often a manned vote with altimeter readings. This can be time consuming and isn't always the best way to include it. Using robotic systems to collect this data can be quicker, easier, and more accurate. Although ROVs aren't typically the most used option for collecting bathymetric survey data, they can be really helpful in hard to reach locations where surface vessels aren't able to go. So using an ROV with the DVL on the bottom, in combination with our location features, will give you all the data needed to collect bathymetric survey materials. Deep Trekker is compatible with software such as Reefmaster or Sound Tiles, which allow you to create detailed maps of your underwater environments.
So ghost gear is any fishing gear that has been lost from fishermen and is just floating around the ocean. It's a problem because it is catching fish as it's going, even though no one is retrieving it. So there's just a bunch of fish and different marine life that get trapped in these traps and they die. They get entangled in whales, they catch like rogue like lobster, they'll all just die in there. So really, to be able to take that out of the water, it protects a lot of marine life.
Traditional methods of cleaning this up can be very disruptive to the ecosystems that live at the bottom, including dredging or dragging underwater to collect that. And they're really inaccurate at some points when you don't know what's down there. You're just taking a guess and you're launching this equipment, interrupting the ecosystem and potentially collecting gear. ROVs take a lot of guessing out of traditional methods for collecting ghost gear. You can either drop the ROV at a location that you already know, where gear is, or you can send the ROV down to do a preliminary inspection, note where different gear is, and then go out and plan a salvage mission afterwards.
When we were cleaning up all the lost fishing gear after Hurricane Fiona, it saved us so much time. So being able to take the ROV where we thought the gear would be, it was the first instance of confirming it and then dropping a scuba diver rather than just dragging the ocean floor blindly.
We were able to collect much larger and much more comprehensive data sets of marine habitats and marine life than we could have before. And then when you complement that with other emerging technologies such as environmental DNA, the ability to describe a marine community even in deeper waters is infinitely more achievable than it was before.
For time, it's awesome. We get it done a lot faster. We don't have to wait on tides. We can put her off anytime. Winds, you know. If we got a good anchor or safe place, we could put her off in winds, and it makes availability to the other sites easier, really easier.
And it's also helped some of our graduate students who have been doing, for example, artificial reef monitoring work. Instead of having to rely on divers and their schedules, they're able to be more flexible and be able to get out and do more surveys than they might have done it had they had to rely on the divers to help them.
Kind of gives us this, leverage where people, this is the only offering here locally or even anywhere near us, and probably in the entire state of Florida, potentially even, the US, that we are operating tours with an ROV on board. And that's kind of what gives us that unique sense where we can book more tours, we get people coming. So of course there's that financial investment, but then also the investment on, educating all of these people about the lagoon and kind of creating these environmental stewards to go out in their community and really care about the environment that they're in.
At Deep Trekker, we have a range of ROVs, starting with our most portable eyes underwater, moving all the way up to our most powerful and capable ROVs. Our product range starts with our DTG3 ROV, which we've been making since 2010 and is our most portable and quickly to deploy eyes underwater ROV. We then released our Revolution ROV, which is our largest and most capable ROV that has a 260-degree rotating head and has the largest platform for tools and sensors, as well as highest payload. Our 6-thruster units are a great option because they offer more power and stability, including our new Photon ROV, which was made to be the similar size and weight as the DTG3, but with the capabilities of our larger 6-thruster units. Due to their size, they can only accommodate 1 or 2 sensors on them at a time. So if you're looking for a platform for growth, I would probably recommend our Pivot ROV, which can accommodate most of the same sensors as the Revolution, but has a lower payload and price. The other benefit of our 6-thruster options is that they all have swappable batteries for extended dive times, but if you wanted to operate with direct power, they're all able to accommodate direct power setups as well.
We really wanted something robust, something research grade, something that we could really kind of focus on. This is the technology scientists use. And sure enough, we actually have scientists here utilizing Deep Trekker ROVs.
One of the partners in this project that we're currently working on actually had a Deep Trekker, and they found it really great. And their Deep Trekker was actually several years old. So investigating the type of equipment to use, we automatically reached out to them because there was such great success and it was such a durable, and it was used like in coastlines and in salt water by other indigenous groups. And we thought it was the best fit to use that.
Well, for the Deep Trekker ROV, the larger ROV is able to keep its position a lot better than the smaller ones. So where we're working in rivers and places with a lot of current and tides, the Deep Trekker ROV really holds its place a lot better than some of its competitors.
The price point was fantastic compared to other groups, and the Pivot had everything that we felt like that we needed, plus the available add-ons were also of interest to us.
Most of our ROV packages come with 75 to 300 meters of tether, but that can be custom extended to kilometers long. One of the defining features of Deep Trekker ROVs is the fact that we have a rotating camera head on all of our units. So each unit that we have has the availability to look all the way above it and all the way below it, as well as everything in between. So another key feature of the Pivot and Revolution ROV is that their depth rating goes all the way down to 305 meters deep. So ROVs are very dependent on their environment. So some of the questions that we ask to determine which ROV will be best for your application is, what is the current that the ROV will have to battle? What kind of payload does the ROV need to carry? And how deep does the ROV need to go? The Deep Tracker camera is great for marine sciences. You're going to get great resolution on your pictures and videos when you're underwater. But it also has software in the back end that helps improve the camera, such as our auto white balance or our turbidity filter, that helps bring forth more details even when visibility isn't great. The Deep Tracker camera has an auto snapshot feature built into it, which is often used for 3D modeling. And so if you are looking to take the pictures needed to process 3D models, you can toggle it on in our menu setting and it will automatically take photos at whatever rate you've set it to. You can then take those pictures and upload them into 3D modeling software to create 3D models of whatever feature you're looking at underwater. Sonars are one of the most important features that we can add to an ROV, specifically when you're working in low visibility waters. There's two common situations where we would use sonar. High frequency sonars are great for looking at things in fine detail. They'll give you the highest resolution picture at a close range to whatever you're looking at. The other situation where we commonly use sonars is when you have low visibility. And so you can use a lower frequency sonar with longer distance or longer range to it to identify targets. So Deep Tracker samplers are an awesome add-on for marine science customers. We offer a range of different water samplers in terms of size, all the way from 100 milliliters to 2.5 liters. We also have an excellent sediment sampler that's sealed, and so you can take 500 cc's of sediment as well. A common application for marine science customers is taking water quality analysis data. And so Deep Tracker offers a multi-parameter sonde that can be attached to the ROV, and it can accommodate up to 4 sensors at a time. So whether that's turbidity, temperature conductivity, chlorophyll A, or a rugged dissolved oxygen sensor, those can all be added to the ROV and collect data as you're swimming. So Deep Tracker ROVs come with a laser scaler built into their camera heads. It's a really wonderful tool for marine biologists or different kind of research where you're looking to size or size reference different objects. Sometimes you can be underwater and see something, and if you don't have a reference point for how big something is, it can either appear gigantic or very, very tiny. And so it's just something to help with the accuracy of the data that you get from our camera. So the grabber arm on a Deep Tracker ROV is a really wonderful attachment. It's a very dynamic attachment. And with the grabber arm, the claws can be removed. So depending on what you need to do, we have different kind of claw attachments if you're looking to pick something up underwater. Another common application is sensor retrieval or salvage missions. And so one of the attachments that's commonly used is a 5,000-pound rated carabiner for doing sensor retrievals or object retrievals underwater. So location mapping is a great feature for our marine science customers because most of our customers are looking to collect data. An extra layer to that is knowing exactly where that data is being taken from. Mission Planner is a really great feature that allows you to plot points of interest ahead of time and then upload that mission into the ROV. Or if you're piloting and you are finding points of interest and you drop those locations, it will record that as a mission and then you're able to analyze that data afterwards. For GPS positioning underwater for marine sciences, it's a really great tool. And there's 2 ways that we offer this feature on the ROVs, depending on the environment that you're operating in. The first combination I'll talk about is DVL with a USBL sensor. So the DVL is a small add-on that goes on the bottom of the ROV, letting the ROV know if it's drifted at all, side to side, forward or backwards, while battling current. In combination with the DVL sensor, you have a USBL sensor, which has a topside beacon that's deployed from either a boat or from a dock, wherever you're operating from, and the other sensor goes on the ROV. These 2 sensors will speak to each other with acoustic pings and triangulate to find out where the ROV is underwater. Using these 2 sensors will give you access to Mission Planner on our controller, where you can map the ROV on Google Maps. So the other option that we have for GPS underwater is using a DVL sensor, and in combination with Sensor Pod Plus, which is integrated into the ROV, and it gives you all the telemetry, so if the ROV has moved at all. Using those 2 sensors will give you a dead reckoning way of positioning. So it maps the ROV from an initial point of deployment. This is really helpful for people that are in situations where USBL isn't available, specifically shallow water applications. This still gives you access to our Mission Planner feature on our ROVs. Both of these are great settings, and we would speak with you about your application, about which one works best. Our Bridgebox feature allows customers to connect to office setups, computer setups. It allows you to operate remotely if you want to use a game controller or different kinds of controls such as a keyboard to operate your ROV, you're able to do so. Bridgebox is a great add-on if you find that you have lots of people huddling over your screen. This allows you to fully operate from a larger platform. Deep Tracker is really special because we do everything here in-house. So from the design of the ROV to the engineering of it, the build of it, and then the conversation that we have with you as a customer, we're a whole team that works together to support you. And it's not just before you purchase an ROV, it's also after. If you want to expand your projects or if something ever goes wrong on site, you always have our team behind you to support you through those situations.
So we did some research, we got in contact with some sales representatives and we're kind of bouncing ideas like, hey, this is what we want to do, will it work? And they were so helpful. I mean, this has been the best experience we could have asked for.
People who work with Deep Track is awesome. We've got an awesome relationship with them. Info, if we need any info, we just pick up the phone and give Blake or someone a call. And, it's really, the communication is really good.
They're really there to please and make sure that what they're producing and selling is always going to be working well. So that's probably my favorite part.